Okay, we want to find the exact values of the modulus and the argument of z equals to negative square root 3 plus I and w equals to 4 plus 4i. Okay, so very quickly, z equals to negative square root 3 plus I. You can see that very quickly. I hope you are able to realize that the real part of z is equals to negative square root 3, and over here the imaginary part of z is 1. Okay, so don't go and say that the imaginary part of z is I. Alright, so quickly, the modulus of z is just equals to square root 3 square plus 1 square and square root, and you actually have a square root of 4, so it's equals to 2. And the argument of z, okay, we need to take a look at it. For example, just to see that which quadrant it belongs to, right? Negative square root 3 and 1. Okay, so this is the real part, red axis. This is the imaginary axis, right? This is your complex number here. This is our argument. Okay, so very quickly you can say this actually is pi minus tangent inverse of opposite over adjacent, so it's 1 over square root 3, and your answer comes out to be pi minus pi over 6, which is 5 pi over 6. Okay, and from here, what about w? Okay, so w is equals to 4 plus 4i. Okay, and the modulus of w is just equals to square root of 4 square plus 4 square, so it should be the square root of 16 plus 6 is square root of 32, and square root of 32 is just equals to square root of 16 times square root of 2, which is equals to 4 root 2. Okay, and okay, so with that, what about the argument of w? The argument of w, okay, and we can see that actually if you draw out on the Argand diagram, okay, the argument of w is just in the first quadrant, right? This is just represented by the coordinate 4 4, right? And from here, this is our argument. Okay, so it's just equals to tangent inverse 4 over 4 is just 1, right? And you can see it just equals to tangent inverse 1, which is just pi over 4. Okay, with that, you have the argument and the modulus of w, you have the argument and the modulus of z. First, we want to evaluate is a negative 1 over z. How do you evaluate negative 1 over z? I just hope, again, you can remember this. We talked about this in the BMQ, that the argument of z1 over z2 is the argument of z1 minus the argument of z2. Okay, and the modulus of z1 over z2 is the same as the mod of z1 over the mod of z2. Okay, and from here, alright, if we were to look at the evaluate the first one, negative 1 over 7, right? First, what you can do is perhaps let's find the modulus of negative 1 over x, 1 over z, sorry. Here, negative 1 over z, you can see that it's just the same as a negative 1 mod negative 1 over mod z, right? Mod negative 1 is just 1, and mod of z, as we have found earlier, right? We have found earlier, mod of z is just 2, right? It's just 2, so it's just 1 over 2. Okay, and what about the argument of 1 over z, negative 1 over z? Argument of negative 1 over z is the same if we were to treat them as the different complex number minus the argument of z. Alright, because what I do is actually I see this as one complex number. The first z1 to be negative 1. Okay, I see this as my second complex number, z2. So I use argument of z1 minus argument of z2. And with that, what is the argument of negative 1? Argument of negative 1 actually is very easy. If you recall the Argand diagram, right? Negative 1 is purely real. So negative 1 is here somewhere here. Right? Negative 1. So again, the argument is just what? What's the argument? The argument is just pi. Right? This is the real part. This is the imaginary part. Okay? And from here, we have the argument of negative 1 to be pi. And the argument of z, as we have found earlier, is 5 pi over 6. Okay, and the answer turns out to be pi over 6. Okay. Okay. And from here you have the modulus, you have the argument of part 1. Okay, so quickly, negative 1 over z, which is your part 1 answer. Okay, it's just equals to half of r cos theta plus I sine theta, writing it in the polar form. Alright, if you want to write it in the conditional of analysis, it's up to you. Okay, so but the question asks for to leave the answer in the exact polar form. So that's what I'm doing here. I went to find the r, I went to find the theta so that I can express my answer in polar form.